Okay guys, I want to show you something that I think is going to help you understand radial and in-track motion a lot better. Here we have the standard setup. I've got an origin at the geo belt and I'm going to be doing some maneuvers. So I've got an in-track maneuver, a radial maneuver, a negative in-track maneuver, and a negative radial maneuver. None of these shapes should be that shocking to you. We've got a drifting NMC for the in-track to the west. We've got a negative drifting NMC to the east for the negative in-track. Positive radial creates an NMC that moves up first, and negative radial creates an NMC that moves down first. So the question I want to ask you guys is, after 1 hour, which of these do you think will be the furthest to the west? Here it is, 1 hour. Who's furthest to the west? It's the negative in-track, right? That kind of makes sense because it starts out moving negative in-track, and you would expect that the one that did the negative in-track burn is the furthest to the west. What about 2 hours? Okay, still negative in-track, but the radial is clearly catching up, at least if we imagine a line of who's the furthest to the in-track. Negative radial is obviously nowhere near the west or negative in-track and never will be. And then you have the in-track, which is actually the furthest to the east, or the positive in-track, which also makes sense. Okay, so who's going to be ahead after 3 hours? The radial burn, yep, that makes sense. The negative in-track is starting to have its motion pulled back to its origin. It's going to tip over this point around 25% of its period, and then continue to move in-track. Okay, we're 6 hours in, and the radial is still the champ when it comes to who is the furthest in-track. Now we're at 8 hours in, and the in-track has finally started to catch up in the in-track direction. And then after that 8-hour point, in-track will be the dominant factor, moving to the negative in-track. So kind of what I want you to take away from this first thought experiment is, if I want to move negative in-track, and I only have 2 hours to get more negative in-track, then a negative in-track burn is actually the best burn that I can choose. Somewhat non-intuitive because we know that eventually a negative in-track burn will always move us relative to the positive in-track of our origin. If I have 2 to 8 hours, then a radial burn is actually my best choice, because you can see that a radial burn moves the furthest in-track around that 8-hour point. And then because its in-track motion is slowing down and getting ready to move back to the origin, the positive in-track is eventually going to be the one that wins the day. Okay, so let's do something a little bit more complicated. And let's look at this in-track burn here. So I do this in-track burn, and now I want to do another series of burn. A positive in-track, a positive radial, a negative in-track, and a negative radial. So here they are. So now my question is, who's going to get the furthest to the negative in-track direction, or to the west over here, after a set amount of time? So after 1 hour, which one do you think will be the furthest to the west? Oh, it's the one that did the negative in-track burn. I forgot to mention that all the magnitudes between these burns are equal. They're each doing 5 meters per second, just arbitrarily chosen. All right, who's second? It's going to be the positive radial burn. Who is third? Actually, it looks like the negative radial is the third, and then fourth is going to be the in-track. What about after 2 hours? Who's the furthest to the west? Zoom out a little. It's still the negative in-track. This number should sound familiar to you, but after 3 hours, who's in the lead? It's the radial burn. Okay, now after 8 hours, which would be t plus 9, who's in the lead? Still the radial, but then as you get to the 9-hour point, the in-track burn is leading the way. You can also see that the negative in-track burn is the furthest to the in-track direction, to the east. All of the same principles that we established in our first experiment with the origin have remained true. We can see that in this setup, when we're just referencing the origin, in-track got the furthest after a set amount of time, 9 hours. Radial was second, then negative radial, then negative in-track. If you go back to the origin, after 2 hours, the negative in-track is the furthest, then radial takes over for 8 hours, then in-track dominates for the remainder of time. So it actually makes a lot of sense that this relationship was preserved even after we had changed sort of our original starting motion. What I'm going to do next is I'm going to show you this motion of these objects with respect to just this in-track line that I created here. So here's that. Here's 3D graphics window that is using the in-track line, that first burn, as the origin, and we're just going to see Rick frames around that object from now on. So at v plus 0, we have nothing. 1 hour later, still all these objects are in the same place, and then after the next hour, they perform those burns. Does this shape look familiar to you? The negative in-track burn creates a drifting NMC to the east. The positive radial burn creates a NMC that moves positive radial. The negative radial burn creates an NMC that moves negative radial, and the in-track burn creates a drifting NMC to the west. This shape is identical in principle to the ones that we established around the origin with the other objects. Here's the origin objects. Here's the objects with in-track as the origin. Same principles. The same principles hold true no matter where you are in space and no matter what tortuous orbit got you there. If you want to move the most negative in-track in 2 hours, a negative in-track burn is always your best choice, understanding that eventually you'll move positive in-track. If you want to move the most negative in-track in 2 to 8 hours, then a radial burn is always your best choice, understanding that, again, eventually you'll start to move positive in-track. If you want to move the most negative in-track in 9+ hours, then an in-track burn is always your best choice. It doesn't matter if you're here and you followed some crazy line propagation to get there. At that single instant, if your only goal is to move more to the negative in-track, then you just look at the amount of time you have to get there, and you can very intuitively, just from these basic rules of thumb, figure out which direction of burn you would want to perform. And the principle isn't just true of in-track motion, it's also true of radial motion. So if you ask yourself, who's going to be the furthest negative radial after an hour, what do you think? Absolutely, it's going to be the negative radial burn. All right, what after 2 hours? Still negative radial 3. Looks like in-track, negative in-track is starting to catch up. 4. Now negative in-track is the furthest negative radial of any of these burns. And then ironically, as you start to look out at this space here, there's actually a point where the positive radial burn after 19 hours becomes the lowest object, or the object closest to the Earth. So if I had 19 hours and I wanted to move the furthest negative radial that I could, counterintuitively, I would want to do a positive radial burn. And the same remains true when we do the in-track burn case. Negative radial is the one closest to the Earth, but eventually negative in-track will be the closest to the Earth. And then at some point, approximately 20 hours later, the radial burn will be the closest to the Earth. Right about here. Okay, so just for our final understanding, to make sure that we're getting this, let's take a bet. Let's decide to create 3 objects. One is going to do negative in-track burn of 5 meters per second every hour for 4 hours. One is going to do a positive in-track burn every hour of 5 meters per second for 4 hours. and one is going to do positive radial burns every hour, 5 meters per second. Now, my challenge to you is which one of these is going to get the furthest to the in-track? So after 1 hour, we know for sure that the negative in-track will be the furthest, because this is just the case that we created previously. What about 2 hours? Yep, still we're seeing negative in-track is the furthest. 3 hours? Okay, it looks like negative in-track and positive radial are pulling in line with each other. 4 hours. Now positive radial is in the lead. At 9 hours, the positive in-track starts to catch up. And now positive in-track will dominate the remainder of the race. All we're trying to get at here is if you want to move to the negative in-track and you're doing very short time scales, then negative in-track burns are the way to go. Forget about the 24 hours of motion, just focus on the 2 hours of motion that you care about. If you want to move the most in 4 hours, then positive radial burns are going to be the best choice. And if you want to move the most in 8 hours, then obviously a positive in-track burn is going to be your best choice. Yeah, I hope this helps you better understand how radial and in-track burns work.